All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have here a lawnmower shown weighs 35 pounds. We know we'll put the weight right at our center of gravity symbol. Let's determine what's our force P required to move the mower at a constant velocity, and then what's our forces in the front and rear wheel at the ground. So first off, are we in equilibrium if I'm moving this? Everyone thinks of statics as being nothing is moving, it's static. But technically, remember, equilibrium says our acceleration is zero. If we're moving at a constant velocity, we have no acceleration. So our approach here of applying equilibrium still applies for this, even though we're moving, because acceleration is zero. If we were accelerating, we're moving into dynamics. It's an entire different type of problem then. But also, what do you think we should model these two wheels out as? If we kind of just logically think about that, I would say that's probably a roller. We should be resisting forces perpendicular to the ground. And that's exactly what we end up doing. A wheel is inherently a roller. So let's come in and try to sketch this one out. We're going to model this entire lawnmower as just a box, just to make it easy. Cut down on our weird drawing, because I am terrible at drawing pictures. So let's not do that if we don't have to. Draw it as a box. At the front of the box, I'm going to have one force from a roller. At the back of the box, I'm going to have one force from our roller. Rollers are always perpendicular to whatever surface they sit on, so perpendicular to the ground. At the back, let's call this AY and BY up there at the front. I also know I have the weight in here, should be going straight down. That weight, we were told, is 35 pounds. 35 pounds. And notice in our picture here, we're given a rotated axis. Rather than X going straight to the left or straight to the right and Y going straight up, X is inclined, parallel to the ground. Y is perpendicular to that. We're going to work with those. It will make our work a tiny bit easier. If we didn't catch that, we'd get the same answer. But this is our X axis. Perpendicular to that, going up and to the left a tiny bit, we have our Y axis. Two axes in here. That weight is, I should redraw my weight line because it looks like it's going parallel to Y, and it is not. It is straight up and down. It's going like that, 35 pounds. If we show its line of action up here, if our axes weren't rotated, Y would be perfectly straight up. We rotated X up 15 degrees, which means we rotated Y over 15 degrees. Or this angle right here is 15 degrees. So I can get that labeled in here. I also can come in and say, I need some dimensions. We have 13 inches from A to the weight, 14 inches from the weight up to the front roller. And then vertically in our Y direction, from the ground to the center of gravity is given as 4 inches. The last thing we need to deal with is that force P. I could come in here and say, I could show the handle on that, and then way out here put in a force P. We have some dimensions and an angle I could work with to figure out where that's at. Or I could be lazy with that and say, it's way easier if I didn't have to find all of that. Why don't, if I remember, I can slide force anywhere along its line of action. If that line of action of P goes straight down along the handle and hits the dead center of my back tire, why don't I just slide that force down its line of action? I'm going to come in and show this all the way down here at A. That's my force P. And it, from the ground, is 30 degrees. That's going to make my work way easier for me. I don't have my force off in nowhere. It's right at A. It's going to make so many moments a lot easier for us. But how many unknowns do I have? I have AY, BY, and P. I should be able to get all of these. The reason that rotating my axes on this helped is because both of these are entirely in the Y direction. Perpendicular to the ground. If we set the X-axis parallel to the ground, then the rollers only have a Y component. I could actually just start here and sum forces in the X to get P figured out. So start there. Summing my forces in the X direction. Summing forces in the x direction. We have, well, P is going to have an x component. It should just be P cosine 30. And our weight should have an x component. It is that x component, well, our angle symbol touches y. That means our opposite sign goes to our x component in here. When it's pointing in the negative x direction, so minus 35 sine 15. Minus 35 sine 15 gets us to 0. Equals 0. And that force to be moving at a constant speed, constant velocity, works out to be that P equals 10.46 pounds. From here we can come in and say, well, what about AY and BY? What do I want to do to get those? Why don't I sum moments up? Let's do moments here at A. That will get rid of P and AY. B will be my only unknown. So with positive going counterclockwise, let's sum up our moments about point A. That'll get me 13 plus 14, 27 BY, and it would cause a counterclockwise rotation. So this equals 27 BY. Our weight is going to have moment from the Y component and from the X component in here. So I'll have two terms to get in here. Let's get that Y component in there first. So in the Y direction here, if I rotate, it would go clockwise. So minus 35 cosine of 15 force times my distance should be an X distance, 13 inches times 13. And then finally, we can get our X component in here. That X component will be up above the ground, pointing down and to the left, going in the negative X direction. That will cause a counterclockwise rotation about A. So we'll add that in. Plus 35 sine 15 times my vertical distance in the Y direction is 4 inches. Times 4 gets us to 0, equals 0. Solving for BY, my only unknown, I'm going to get that BY is 14.94 pounds, and it's going up and to the left. Up and to the left in our rotated Y direction entirely. Finally, I can get AY out. If I just sum forces in the Y, summing my forces in the Y, or I could sum moments about any point its line of action doesn't pass through, but forces in the Y will be easier. I have BY 14.94. I have a Y component of P minus P 10.46 times the sine of 30, sine 30, and I have the weight. I'll subtract off the Y component, so minus 35 cosine 15. And then finally, plus my last piece, I need to add in AY. Plus AY equals 0. Which if I solve that for AY, I'm going to get here that AY is 24.1 pounds, and it's going up and to the left. Which would be our final answer for that problem. We can get through rigid body equilibrium. Again, keep fighting with these ones. If we're struggling with them, they will keep showing up in our class here. They will keep showing up in your follow-up classes to statics. This becomes one of our really key concepts for us all the way through engineering. So stick around. If this is useful for you, hit the like and subscribe buttons, and let's get you an A with JJ.